Hey guys, Mr. T here. This is another video. This one is on solution by elimination. This is maybe the trickiest method of solving simultaneous linear equations. And it's used when both equations are given in general form. So the variables on one side of the equation, such as ax plus by is equal to c, where a, b, and c are just numbers, integers. So to solve by elimination, there's 4 steps. Keep this in mind, okay? So number 1, choose one of the variables in either equation. You just choose x or y. Number 2, observe the coefficient, so the number in front of that chosen variable, in both of the equations. Step 3, you would be determining the operation you need to perform to make the coefficient in one of the equations you're looking at equal in size but opposite in sign, plus or minus, to the coefficient in the other equation. So you're looking at the number in front of a particular variable, say x, and you're working out what you need to do to one of those coefficients to make it equal in size but opposite in sign to the coefficient in front of that same variable on the other equation. We'll see how that works below. Step 4, apply that operation to each term in the equation that you were looking at. In some cases, you might have to apply operations to both equations if they're not factors or multiples of each other. So if they don't fit neatly, if one doesn't fit neatly into the other by multiplication. So I think this example shows that, so that you don't miss out. Now let's give it a go. Example, let's solve the following simultaneous linear equations by elimination. Why would I do it by elimination? Because they're both provided in general form, and I'd rather not be drawing the graph today, and maybe the graph would be on fractions of points rather than on nice even points, so I'd rather just solve it by elimination. So what am I going to do? Step 1, choose a variable. Choosing... I'm just going to choose x. Observe the coefficients of the variable. So in equation 1, the top one, coefficient is 3. In equation 2, the coefficient is 2. Determine the operation required to make coefficients equal size, opposite sign. There's nothing right now that I can do in one step to make 3 and 2 equal size and opposite in sign. They're not clean multiples of each other, or factors of each other. So this is one of those cases where I need to apply operations to both equations to make them the same number. So what's a number that both of these go into evenly? Well, 6. You can often find the first number by just multiplying those numbers together. 3 by 2 makes 6. So to make the coefficients even, I would need to multiply 3 by 2 and 2 by 3 to make 6. So that makes them equal in size. To make them opposite in sign, I would need to times 1 by negative. So 3 times by negative 2 is going to make negative 6. So now I've decided that in equation 1 I'm going to times by negative 2, and in equation 2 I'm going to times by positive 3. That will make the coefficients both 6, but one of them is going to be the opposite sign at negative. Apply the operation to all terms in the equation. So I'm going to rewrite the equation. 3x plus 4y is equal to 2. 1. 3x plus 4y is equal to 2. 2x take 3y is equal to 7. And in the previous step, I decided I was going to times the top equation by negative 2, times the bottom equation by 3. So step 4 is apply the operation to all terms in the equations. So I'm going to times all of these terms by negative 2. Negative 2 times by 3x is going to be negative 6x. That's what I was trying to do. I wanted it to be equal in size, opposite in size. So negative 6x. Positive 4y times by negative 2 is going to be negative 8y. And the last term, negative 2 times by 2 is going to be negative 4. So I've done the times by negative 2 on the top line to all the terms. Times the bottom line, all the terms by 3. 2x times by 3 is going to be 6x. Now you can see that the coefficients of x are equal in size, opposite in sign. Negative 3y times by 3 is going to be negative 9y. And 7 times by 3 is 21. So after that, we have dealt with the equations, made them equal and opposite in size. The last step is going to be to add the equations together. So essentially what you're doing is negative 6x take 8y equal negative 4, and 6x take 9y is equal to 21. You're adding them vertically. So negative 4 plus 21 is going to be... It's not working today. Let me use a calculator. Negative 4. I think it's 17. Negative 4 plus 21. 17. Yay! 17. Negative 8 plus negative 9 is the same as taking... just taking 9 from negative 8. So negative 8 take 9... take 9 is going to be negative 17y. Negative 6x plus 6x is going to be 0. So what do we have left over? Therefore, negative 17y is equal to 17. If that's the case, and I want to get what y is, we need to remove the timesing by negative 17. What's the opposite of timesing both sides by negative 17? Dividing both sides by negative 17. That cancels, we have y left over. 17 divided by negative 17 is going to be negative 1. So that gives us part of the solution. We know what y equals now, and like last time when we worked out only what half of the solution was, we need to substitute that into one of the equations. Let's use 3x plus 4y is equal to 2. I know that y is equal to negative 1, so I'll plug that in wherever y is. 3x plus 4, y is negative 1, is equal to 2. 3x, 4 times negative 1 is negative 4, is equal to 2. 3x. Take 4. The opposite of taking 4 is adding 4. Need to balance that out on both sides. 3x. Negative 4 plus 4 is 0. 2 plus 4 is 6. Opposite of timesing by 3 is dividing by 3. 6 divided by 3 is 2. Therefore, solution is x is equal to 2, y is equal to negative 1. We can check that by plugging those numbers into the other equation that I didn't use. 2x take 3y is equal to 7. Is that true if x is equal to 2 and y is equal to negative 1? I hope so. 2 lots of 2 take 3 lots of negative 1 is equal to 7. Is it? 2 times 2, 4. Negative 3 times negative 1 is positive 3. 4 plus 3 is equal to 7. Therefore, the solution is x is equal to 2 and y is equal to negative 1. So, something I just have to add to the steps. Really, there's a fifth step. Fifth step, add the equations together to solve for variables. Alright, so hopefully you have seen from that the process of solving simultaneous linear equations by elimination. I could have easily done it by choosing y instead, and their coefficients are slightly different, 4 and 3. I would have timesed the top line by 3 and the bottom line by 4 because they're closest multiple, the closest multiple is like 12. 4 times 3 is 12. And so the coefficient I would have been using was negative 12 and positive 12, but you still would have come up with the same answer anyway. Whatever you choose, the steps I'm giving you will work whatever pair of simultaneous equations you get. Alright, so hopefully that helps you out with that particular type of simultaneous equation solving, and I'll see you in the next video.